Okay, so let's start from the first one. So just get understand. A current of 4 amps flows from a battery when a light bulb is connected across its terminals. Okay, so you can even make a picture. Got a battery, and then you have got can have something like that. Okay, so a current of 4 amps flows. So we have got a current of 4 amps that is moving in this circuit like that. The PD across the terminals is 12 volts. That's a potential difference. Potential difference or EMF, electromotive force or voltage, is basically the same thing. So what quantity of charge flows in 1 second? You know, charge is simply current times time. So therefore, charge is going to be current, in this case is 4 amps, times time. They've said in 1 second, so times 1 second. Now another thing that you can maybe know is that charge is measured in amps, and 1 amp is one equal to 1 coulomb per second. So make sure that even the time you're multiplying with is in seconds. So charge therefore is going to be equal to 4 coulombs. And then for question B, how much energy does each coulomb leaving the battery possess? Each coulomb leaving the battery. So energy is actually charge multiplied by voltage. Okay, so this will be charge. They've said each charge. What does each mean? One. So that would be 1 coulomb multiplied by voltage. So voltage in this circuit is 12 volts. Now a volt give is the same as joule per coulomb. Like 1 volt is joule per coulomb. So this coulomb and this coulomb will cancel. Therefore energy will be 12 joules. And then C is saying how much charge must be given out by the battery if it is to supply 60 joules of energy. Mhm. Uh, the same voltage that you've been given, just multiply by the charge balandile. If it is, let's say, 1 coulomb, then multiply by 1. If you are multiplying by 2, then you are 11 2 times 12, that will be 24. But because I've said each coulomb, meaning that we're talking about 1 coulomb. So if they didn't say each, they would have told you how many coulombs you need to transfer. So if they said 2 coulombs, how much energy does the 2 coulombs leaving the battery possess? Then you use 2. And then see how much energy must be given out by the battery if it is to how much charge must be given out by the battery if it is to supply 60 joules of energy. Now the same equation, energy is charge times the voltage. So energy, they've told you if you want to supply 60 joules of energy, so it says 60 joules, and then you don't know, you want to find charge. But what's the voltage in this question? The voltage is 12 volts. So if you want to remain with charge, divide both sides by 12 volts. Okay, divide this side by 12 volts. Therefore, charge is going to be 12 into 60. How many times is it going to go there? That's 5 times. So meaning that the answer is going to be 5 coulombs. Is that okay? And then part D. How long does the battery take to supply 60 joules of energy? So if they ask to say how long, what are they trying to look for? What do they want us to find? Time. Okay. So charge, yes, that's correct. So charge is actually current multiplied by time. So in this question you already know the current and we have already found the charge. Okay, we've already found the charge. So you can just go like direct like that and get to find what the time is going to be. Charge, we want to supply 60 joules of energy. Charge in this question is we've calculated 5, and then the current in this question is 4, and then multiply by time. Now remember, for this question, have they told us anything about the, let me say, the current? They have not mentioned the current in this case, right? And they've not mentioned, yeah, they've not mentioned the current. All they've mentioned is energy. So we'll try to use an equation that has got energy in it. But still more, it will come back to the same thing, because all these quantities in this question have got a relationship. Okay, so if you want to find something that has got like time in it, actually you know that charge is current multiplied by time. From this equation you can as well determine to say, uh, you can substitute where there is current here. Current is also given as voltage over resistor. Now we don't even know the resistance in this case, so we can just get to leave it there. But if we want to have energy in the equation, we know energy, we already mentioned to say energy is voltage multiplied by charge, or charge multiplied by voltage. I think this one we already mentioned. But since I want to find time, we know that charge is current multiplied by time. So where there is charge, I'm going to substitute with current multiplied by time. So I'm going to have energy being equal to voltage multiplied by current multiplied by time, like that. Okay, so that is the equation that we are going to have. And we know that voltage multiplied by current is power. So energy is simply power multiplied by time. But in this question we don't know the power, so we'll just use here. We've already been told energy should be 60 joules, and that should be equal to voltage. Voltage in this question is 12, and then current is 4, and then multiplied by time. So this is going to be 60 joules is equal to 12 times 4, that is going to give us 48 multiplied by time. So to remember, how can we find time in this case?
We divide both sides by 48.
Okay, so time is just going to be 60 divided by 48, and that will give us 1.25 seconds. We could have used this formula. Let's see what we would have found. Charge is 5. This is the one we calculated here when you have got 60 joules. And then current in this question is 4 multiplied by time. So if we divide like 5 divided by 4, that will give us 1.25 seconds. So whatsoever you use, you are going to find the same answer. Is this okay? Yana chilafu kumfeniso. Or maybe you can't see what I've written. Just a moment, I think you can see. Okay, the one I wanted to use is that one, which I've showed an arrow. You see that they've given the same answer. Okay, let's go to this one. State the equation connecting voltage, current, and resistance. What is the equation connecting voltage, current, and resistance?
G random.
Eh?
Voltage equals to current times resistance.
Very good. So that is the equation. And then for part 1, a current of 2 amps flows through a conductor. The conductor has a voltage of 12 volts across it. Find the resistance of the conductor. Okay? A current of 2 amps flows through a conductor which has got 12 volts. So where there is V, I'm going to put 12 volts. And that is going to be equal to, where there is current, I'm going to put 2 amps. And then multiplied by R. We want to find R. So divide both sides by 2 amps. So the resistor is going to be, this will cancel with this. So 2 amps into 12 volts is going to give us 6. Now the unit for resistor is ohm. So that is going to be it. That's okay?
Yes, yes, yes.
Okay. The next one. An electric bell has a resistance of 4 ohms. When it rings, the current through it is 3 amps. What voltage must be used to operate the bell? So voltage is current times the resistance. Okay, when it rings, the current through it is 3 amps, but it has got a resistor of 4 ohms. So this will give us 12 volts. Very direct, isn't it?
Direct.
Okay. Next here, the the diagram below shows the 4 ohm, 6 ohm, and 8 ohm resistor connected in series with a 3.6 volts battery.
That's a.
Mhm.
But before the Murasanga, I did the children to me.
Oh, okay. So what we are going to do is this: you be writing the answers to this which you are solving, and then you send them in the you send them after then, and then I'm going to mark you, or you can mark yourself, and then you tell me what you got. Okay. So question A. Calculate the effective resistor. So effective resistor is also called total resistance. So resistor effective, when resistors are in series, okay, like this, they're in series, just add 4 ohms plus 6 ohms plus 8 ohms. So just say resistor 1 plus resistor 2 plus resistor 3. This is going to give us 18 ohms. And then for B, calculate the current delivered by the battery. We already know that voltage is current times the resistance effective. This is the effective resistor or the total resistor. Voltage is 3.6. That will be equal to current multiplied by the effective resistor, which is 18. So to remain with the the current, we divide 3.6 by 18. This is going to give us 0.2 amps. And then part C, calculate the voltage across the 4 ohms resistor, 6 ohms resistor, and 8 ohms resistor. So let's start with the first one, 4 ohms resistor. We want to calculate the voltage across. So we know voltage is equal to current multiplied by resistor. Okay. So therefore, voltage is going to be equal to current flowing through this circuit is the same. It is O which one it has been given. It is O. Which one have we calculated? Current, we've calculated 0.2.
0.2.
So that would be
That is
0.2.
fast. Wednesday.
And then the first resistor is 4. So we'll multiply 0.2 times 4. That is going to be 0.8
0.8.
volts. And then 2, voltage will be 0.2 multiplied by 6.
1.2 watts.
Okay, 1.2 volts. And then the next one
0.2 times 8.
times 8,
1.6.
1.6 volts. And then calculate the voltage across the three resistors. Calculate the voltage across the three resistors. So now you need to add this. Voltage across the three resistors is going to be 0.2 plus 0.8 plus 1.6.
Answer of 3.6 voltage. Watts.
Okay, let's see, 0.2 plus 0.8 plus 1.6. What is it producing?
3.6 volts.
So which one have I not multiplied in the I was supposed to say 0.8 plus 1.2. So it is the 3.6 volts. It's supposed to be the same as the one which is given here. Supposed to be the same.
Nadire tonso.
Okay, nice. Let's consider this one. The diagram below shows a parallel circuit. Find the total resistance. Now for a parallel circuit, total resistance, you say resistance total is going to be given by R1 plus R2 divided by R1 R2. So here I've got R1. I've actually swapped this. Supposed to say that's part 1. 1 over R total supposed to be equal to 1 over R1 plus 1 over R2 when the resistors are in parallel. So from here I can also say this is 1 over R total. This is going to be, I want to make this as a single fraction. I'll get this, I'll multiply with what is down. So that will be R2. I'll get what's down, I'll multiply with what's on top. That is going to be plus R1. And then I'll multiply the two denominators, these two. That is going to be R1, R2. So if I take R total on top and then 1 comes down, we are going to have R total being equal to, so this is also going to go on top. That will be R1, R2, and then divided by what is on top comes down, R1 plus R2. Therefore, R total is going to be R1, we can say 2 multiplied by R2, which is 3, then divided by R1 plus R2. This is going to give us 6 over 5, which is 1.2 ohms. Is that okay?
Nadire tonso tobasa.
Calculate a current through the 2 ohms resistor. Now, this one maybe is going to be a bit of trick. When you want to calculate the current which is passing through here, okay, and the current which is passing through here, maybe this can be a bit of trick. So current through a 2 ohms resistor, you know that current is given by what? Voltage is current times resistor, meaning that current is voltage over resistor. Okay, so that will be, current is going to be voltage over resistor. The voltage in this question is what? 6 volts. And then the resistance is 2. This is going to give us 3 amps. And then the current through the 3 ohms resistor is also voltage over resistor. Voltage is 6, and then over resistor, which is 2. I mean 3. So this is going to give us 2 amps. So if the resistance is high, the current is going to be low. The resistance is low, the current is going to be high, just like that. Okay? And then for B, explain the advantage of parallel connection over series connection. The advantage of parallel connection over series connection. So the advantage is it lowers the resistance, and when the resistance is lowered, more current is able to pass. Okay, look at this. This was 2 ohms, and then this is 3 ohms. After finding the total gave us 1.2, which is small. But if these were in series like this, 2 ohms and 3 ohms, to find the total would have just added 2 plus 6, would have given us 5, meaning that the resistance would have been higher. Okay, so in series in parallel the resistance is going to be lowered, and that is an advantage because more current is able to pass.